So from Datasport, we have some other problems with them because we are working with MYLAPS controllers and we are working with RACESALT. So we have to push the data from the MYLAPS controller into RACESALT because it's not really working that you can work directly with MYLAPS decoder, same as the RACESALT decoder, because RACESALT is not interested in this, for sure. That's why we have our own adapter to put the times from the MYLAPS software into RACESALT, that we can work with RACESALT. Good. For this, but to put them inside the RACEMAP, we will need the RACEMAP forwarder. This is a tool from Jens. We need the timing and scoring. Oh, it's already open. We need the timing and scoring software from MYLAPS. And we also have this small data here. So I can start the RACEMAP forwarder. I can see nothing. Usually if something is connected, it's connected right here.
Yeah, you get a special line for connections.
Yes. And here in the RACEMAP, I already put it as a new measure point, call it test. This is this decoder. It's already on. And the problem is I have to put here an exporter. I put here new exporter, set. I would like to send the test. Sorry.
So that's a feature from the timing and scoring software from MYLAPS. They have some kind of an interface that it's also documented. So I wrote all the documentation about it, and I wrote the other part of this. It's called our to RACEMAP forwarder, and this forwarder should be able to connect different timing data sources. Like we will also use it for chrono check or something in MYLAPS, and if we encounter a new timing system somewhere that has kind of a big usage, we want to integrate it there. So it should always be the same way. Have a timing system, connect it with our forwarder, with a local interface, and then push everything to our servers. This is the idea.
And I will put here the right port, because usually the forwarder is at 1397. Our problem is our adapter is also on the same port, so we change it here to 1398. Yeah. Now we see it's not red, and we must have a connection here.
Yeah.
We have the decoder, the location test. We have the status over there. It's open. And then this is an active timing system, and I have some active chips with me that we can test it. And yeah.
Excuse me. This is the transponder, right?
Yes. Yes, this is the
active transponder.
Yes.
And that's decoder.
This is the active decoder.
Active decoder.
The passive decoder is twice the size and 4 times the weight, so I prefer this one to take with me.
Yeah.
So right
it's
now,
better for the plane.
Yes. Right now we have the 2 detections. And 2 days ago, we created also a test event.
But I have a question, please.
Yep.
What's the distance between transponder and decoder?
Usually we have some antennas here, or we have a timing mat on the system, or we have a loop in the snow or at the floor, a cable, yes. But right now, I didn't took this with me for sure. So I have to go directly to the transponder, then he got the detection. But usually we have a mat about 10 meters or whatever you need.
And you can put it as up or underground? In
the snow, we have some underground loops we put in the snow. We also can do some side panels or some panels on arches. We also use it for cross-country skiing, for example. So it's, yeah, you can do everything you need.
And this transponder, can you use it to motorbike or cycling or just for...
we use them for every sport. We use it for triathlon, we use it for mountain biking, cross-country skiing, alpine skiing. but not really for usual trail running or running events, because for this one is the passive system.
A 2D or 3D transponder?
2D or 3D.
What do you mean with?
The antenna is a 2D or 3D antenna. In the rest of the system, you on basic timing chip, it's 2D antenna. You can't use it on this horizontal way. You need to wear them vertically. And pro active chip, it's 3D antenna. You can detect it in any.
Yes, with this one we can have it like this, whatever you need. But on the passive system, it's also 2D. But this one is 3D in this case.
Thank you.
You're welcome. Here we created already the map. We have a small course in Dresden, and here we have the split.
And this is now the special part, because this timing system is not transmitting its location.
Yes.
It's a little bit more complicated. You have to define a location on the map where you put the timing system, and then it's additional source of error. Because if the guy who is placing it places it here or here, then it's not correct anymore. So, but in RACEMAP you can make a split. You can define the split as a timekeeping one. Then we know, okay, it's somehow involved in the prediction. And then you can go to this list of timing system IDs, and you add the ID here. And it's a list, so you can have, sometimes on the start or on the finish line, you have 3 systems, like 3 decoders, because you want to get sure that you recognize everyone.
Yeah,
so you can put a list there.
As example here, we used at the first spot, we had 2 decoders, or start, we have also 2 decoders. So you can put both on this list. And it must be exact the same name as here. So I call it test here.
Because this is the matching. So we get some reads from 2 timing systems. We look in our map, okay, there's a match, it's called test. And then we use this location for the prediction algorithm. Yeah.
Yes.
So in case the decoder does not provide information which includes the location, we have to, let's say, add the location which is defined through the map settings here.
Yeah.
And then we can go to the prediction. We have the reader here. We can select here the test. That's already done. And somewhere we must have our detections. Received at 10.
Maybe it's because the end time is okay now.
Here.
Yeah.
Right now I can see my 2 readings I got. I also put I imported the participant list from RACEMAP, RACESOLT. I did the matching with the chip codes. So I have these 2 participants, Raffael and Thomas Wiesmüller. And so right now I have the detections here and can work with them. I also have the location there, all we need.
So and this is the kind of the indicator that you have now a manual to configure a prediction location system. Because if we have no match, you see we have no location for this read. We don't know where it comes from. But if you configure this in our map settings, like we showed before, then you know, okay, this is this location. It's yellow indicating it's a user-defined location. So could be an error there. And the matching with the participant, and then the prediction will work. Like all the other systems. And the funny part is that you told me that 2 years ago this system had a geolocation.
Yes.
And with the firmware update it was lost.
This is a MYLAPS problem, unfortunately.
Yeah.
Maybe you have to cut this comment from the recording.
Okay, yeah, we can.
Maybe, yeah. And you could do it the same way with the passive decoder from MYLAPS. So we don't have time to show it, but
yeah. And maybe you can comment on this. Raffael took the time to come here a little bit earlier before the workshop around lunchtime, and we did some software development. And the first read were not recognized because I had to change something with the IDs and the format stuff and so on. But I think after 3 hours or so,
Yes.
We got it working. So thank you very much that you brought the system with you and we could do this testing.
No
It's
problem.
always faster than on the phone.
Yeah,
so-
sure.
And
Yeah.
when do you test it during a real event?
Yes, I will have a cross-country race next week in Switzerland, and I will test it there with the prediction timing. It will be a half-kilometer race on Saturday, or 2 half-kilometer races, and a marathon race. Sorry, not kilometer. A marathon race on Sunday for about 1,500 participants on both days. We have splits every 5 Ks, so it's we will try to test it over there and hope it will all work.
Thanks. That's good. Questions?
Just by seeing the MYLAPS connections with the decoder, with RACEMAP do you filter so as to know which of our hardware is at which timing point? Because through the API you just have the location, but how do you filter that?
I think this decoder has an ID.
I mean, for RACEMAP decoder, we don't have to match between the location because you already have the location from the decoder. But how do you filter? Because from the API that you receive from RACEMAP, you have all the decoder from our account. So if we have, for example, 10 events at the same time, do you have all of them?
Yeah.
Okay, and you filter
But
all.
only some of them are in the near of the shadow track.
Okay, so you compare to the shadow track the distance, and like that you select your devices.
There's kind of an area around the track, and if it's outside, I don't use it.
Okay, so if, for example, if I'm like 2 kilometers from the shadow track and I turn on devices, it will show on the map the device.
No. Also, yeah, it will show in the reader's tab. You will see it.
Yeah.
But it will not have any influence on the participant.
Because you don't have reads related to that. Because on the reads, you compare the localization of the hardware and of the reads.
And then it's also the other way around. For the table, I show everything.
Okay. Yeah.
You see all the signals coming in.
That's why we have here some detection from MS Lomis, for example. We also tested for the passive system on another event, but it was in the same window, so
because
we
it
can also
belongs
see
to
it
his
here.
account, I show it here. But for the algorithm itself, it has the participant list, and I know the transponder ID of the participant. I only take the reads for this guy from the database. So if the guy is not passing the decoder, I have no information for this guy from this decoder, and then it's not considered. So I just take the participant list, get all the signals for them, and then do it.
That is what I say. We don't assume anything despite from the data we really receive. So
Yeah, it's something that I never considered because as you do it automatically, and as I saw that it's different on MYLAPS, I say, okay, how do you do that automatically? So.
And then maybe something from experience. So 1 year ago, we also considered the start signal. So over the race result API, you can give us a start time for each participant. And then we created a read saying, okay, this is a start time. There's a read at the beginning of the shadow track because he started. So we created an additional information to have just one more read at the beginning to start the live tracking earlier, because I explained to you I need to have 2 signals and only on the second signal it starts. So we tried, okay, it's a good idea to have the first signal, it's kind of synthetic. We called it the synthetic read. But there were so much errors with the start times. Some people made a mass start. Some people entered the start times to the database the day before because they wanted to go safe. So gun times. And then we calculated a very slow speed and we sorted out everyone because it's too slow and the algorithm said, okay, it's not possible. So we removed all this code again and we only take reads that you get. So if you want to have the prediction to start early, to have to put 2 decoders, maybe one on the start line and one 500 meters up front, and then there it starts.
500 meters is enough.
Yeah. Most of the guys do warm-up runs. They run over the decoders before the start. So they produce noise. But I think 500 is enough. Some people do 1K. On a city marathon, 1K is also good. But we also have seen 500, 600. Maybe you should not go below this. But
Start line, finish line.
then the same for the finish line, yeah. So then if there are not any questions left, I think it's lunchtime. Thanks all of you for attending our workshop. I hope everyone could take some inspiration with you.